Welcome to the Junos OS Factory Default Configuration module. By the end of this module, you should be able to load factory default configuration using Junos OS. All platforms running Junos OS are shipped with a factory default configuration. All factory default configurations provide access using the root account. The root account does not include a password by default. Setting a root password is required before activating any changes to the configuration file. All factory default configurations also include system logging, which tracks system events and writes those events to predefined log files. An example of a typical syslog configuration found within a factory default configuration is shown. Factory default configurations can vary from one platform family to another, or even between the different models within the same platform family. All platforms running Junos OS are designed for specific roles within a network environment, and their factory default configurations are created with those specific roles in mind. One example is the EX series switches, which are designed to operate as Layer 2 switches right out of the box. To meet this default operational requirement, the associated factory default configurations have all interfaces configured for Layer 2 operation, and also include protocol configuration commonly used on switches, such as the Rapid Spanning Tree Protocol, or RSTP, and the Link Layer Discovery Protocol, or LLDP. Other platforms do not have the same default operational requirements, and thus do not include those configuration parameters in their factory default configurations. Note that VSRX factory default syslog configuration is different from what is shown in this example. In the current version of Junos OS, VSRX factory default configuration does not include the user portion in the syslog settings. When repurposing a device, you might want to return a device running Junos OS to its factory default configuration. You can overwrite the candidate configuration while in configuration mode using the Load Factory Default command. Junos OS does not permit you to save the configuration until you configure the root authentication information as well. Do not forget to issue a commit command to activate your changes. Welcome to the Junos OS System Configuration Tasks module. By the end of this module, you should be able to perform initial system configuration tasks. Always refer to your platform-specific documentation and follow the safety guidelines when connecting power and powering on your device running Junos OS. Once a device running Junos OS is powered on, and if power to that system is interrupted, the device automatically powers on when the power is restored. In other words, no manual intervention is required for the system to reboot in this situation. Junos OS is a multitasking environment. To ensure file system integrity, you should always gracefully shut down platforms running Junos OS. Although unlikely, failure to gracefully shut down the system could possibly leave it unable to boot. Use the Request System Halt command to gracefully shut down Junos OS. This command provides options that enable you to schedule the shutdown in a specified number of minutes or at an exact time, to specify the media which the next boot-up operation must use, and to log a message to the console and to the messages file. Note that the Request System Halt command is no longer valid on some of the platforms. Instead, you can use Request System Power Off to shut down. Please refer to Juniper Network's Tech Library website for specific details. You can access the website from the reference links document. The difference between Halt and Power Off is that the Halt option instructs the hardware to stop all CPU functions, but leaves the system in a powered-on state. This usually means someone has to shut down the machine manually by pressing the power button afterward. The Halt option is useful when managing a device through a console server. It enables you to stop and restart the device in situations where no one is present to manually power on and power off the device. The Power Off option stops the CPU, but also sends a signal that instructs the system to commence with a complete and immediate shutdown. For Junos devices that offer redundant routing engines, You can halt both routing engines simultaneously using the Request System Halt Both Routing Engines command. For EX series switches participating in a virtual chassis, where multiple switches function as a single virtual device, you can halt all participating members simultaneously with the Request System Halt All Members command. When you receive a device running Junos OS from the factory, Junos OS is pre-installed. Once you power on the device, it is ready to be configured. When the initial configuration is performed, the root authentication must be included. Junos OS enforces password restrictions. All passwords are required to be no less than 6 characters and must include a change of case, digits, or punctuation. In addition to root authentication, it is also recommended that you configure these items: hostname, system time, system services for remote access such as SSH, web management, and management interface and static route for management traffic. Remember that when you receive a platform running Junos OS from the factory, the root password is not set. To log into the CLI for the first time, you must log in through the console port using the root username with no password. When configured, the console login displays the hostname of the device. When no hostname is configured, such as is the case with the factory default configuration, Amnesiac is displayed in place of the host name. When you log in as the root user, you are placed at the Unix shell. You must start the CLI by typing the CLI command. When you exit the CLI, you return to the Unix shell. For security reasons, make sure you also log out of the shell using the exit command. Note that in VSRX, the root login prompt at the Unix shell shows hash instead of %. After starting the CLI, you enter operational mode. You can make changes to the configuration only in the configuration mode. Enter configuration mode by entering configure at the operational mode prompt as shown. The example shows how to use the CLI to configure the hostname and a root password. As displayed, a check is made when the root password is entered to ensure that it has been entered correctly. In the event that both the entered passwords do not match, an error is generated. The change is not made, and the password needs to be re-entered. The example uses the plain text authentication option. Unlike the software from some vendors, Junos OS never actually displays the password in its plain text format, but rather encrypts the password for you. You can determine the encrypted password by viewing the relevant configuration. Because you cannot retrieve the passwords by looking at the configuration file, you should keep the configured passwords in a secure location. If you do forget the password and cannot log in, you can always perform the password recovery process. The example shows how to use the CLI to configure the time settings. You can configure the current date and time information along with the proper time zone for the device. The default time zone on Junos devices is UTC or GMT. When you define the local time on a Junos device, you must account for the time difference between the defined time zone and the default time zone. Once the time zone is changed and committed, the local time is adjusted accordingly to account for the difference. If you do not want to make the necessary adjustments, you can simply set the system's time after the defined time zone parameter has been committed. Instead of setting the local time on each network device in your network, you might consider implementing the Network Time Protocol, or NTP. The example also shows how to use the CLI to enable SSH and Juniper Web Device Manager, or JWeb GUI access to a device running Junos OS. The example shows how to enable the HTTP service, which enables the device to be accessed and managed through a web browser. When connecting to a device running Junos OS using one of these access protocols, use the same user logins defined under the Edit System Login hierarchy. By default, root user is not permitted to log in through SSH. To enable SSH access for root user, you need to configure the Set System Services SSH root login allow command. The example shows how to use the CLI to configure a management interface and a static route for management traffic. Note that using a default static route for management traffic is highly discouraged. You should be as specific as possible. You can also use the No Re-Advertise option for the static route used for management traffic. The No Re-Advertise option marks the route ineligible for re-advertisement through routing policy. Note that the static route defined for management traffic or any other traffic is only available when the system's routing protocol process, or RPD, is running. When Junos devices boot, the RPD process is not running. Therefore, the system has no static or default routes. To enable the device to boot and to ensure that it is reachable over the network if the RPD fails to start properly, you configure a backup router, which is a router or gateway device that is directly connected to the local system, that is, on the same subnet. To configure a backup router running IPv4, include the backup router statement at the Edit System hierarchy level. In this sample configuration, hosts on the 10.0.15.0/24 subnet are reachable through the backup router. If the destination statement is omitted, then all hosts are reachable through the backup router. To eliminate the risk of installing a default route in the forwarding table, also known as Forwarding Information Base or FIB, you should always include the destination option, specifying an address that is reachable through the backup router. Specify the address in the format network prefix /mask length as shown, so that the entire network is reachable through the backup router. When the routing protocols start, the address of the backup router is removed from the local routing and forwarding tables. To have the address remain in these tables, additionally configure a static route for the desired destination prefix with the backup router as the next hop and the retain option as shown. Once you complete your initial configuration, use the commit command to apply your changes. You can run the commit and quit option as shown to return to operational mode. In the example, you see that once the configuration changes are activated and the user returns to operational mode, the configured hostname is displayed. This displayed hostname is a sure sign that the active configuration has changed. Use the operational mode show configuration command to display the hierarchical configuration file as created by the initial configuration set statements. Note that the complete configuration is not shown for the sake of brevity. In operational mode, you can control the Junos CLI environment. By default, an individual CLI session never times out after extended times, unless the idle timeout statement has been included in the user's login class configuration. The timeout can be 0 to 100,000 minutes. Setting the timeout to 0 disables the timeout. This operational mode command, set CLI idle timeout, holds good only for the session in use when you enter it. If you need to configure the idle timeout permanently for all the CLI sessions, then configure the idle timeout statement at the Edit System login hierarchy level. The CLI provides a method to display a login message to users. The login message is displayed when a user connects to the host using Telnet or SSH. A rescue configuration is a user-defined known good configuration that is designed to restore connectivity in the event of configuration problems. It is recommended that the rescue configuration contain the minimum elements necessary to restore network connectivity. For added security, the rescue configuration must include a root password. By default, no rescue configuration is defined. You can save the active configuration as the rescue configuration using the CLI's operational mode request system configuration rescue save command. If a rescue configuration already exists, the request system configuration rescue save command replaces the rescue configuration file with the contents from the active configuration. To manually delete the current rescue configuration, issue the request system configuration rescue delete command. Once saved, you can load the rescue configuration by entering the rollback rescue configuration mode command. Because the rollback operation only replaces the contents of the candidate configuration, you must issue commit to activate the configuration. Welcome to the Junos Interface Types and Configuration Tasks module. By the end of this module, you should be able to describe interface types and basic interface configuration tasks of Junos OS. Interfaces are primarily used to connect a device to a network. However, some interfaces are used to provide a service or a specific function for the system on which it operates. On platforms running Junos OS, several types of interfaces exist, including management interfaces, which are used to connect the device running Junos OS to a management network. The actual designation for this interface is platform-specific. Examples include FXP0 and ME0. Internal interfaces, which are used to connect the control and forwarding planes. The actual designation for this interface is platform-specific. Examples include FXP1 and EM1. Network interfaces, which are used to provide media-specific network connectivity. Some media examples include Gigabit Ethernet, or GE, 10 Gigabit Ethernet, or XE, 40/100/400 Gigabit Ethernet, or ET. Services interfaces, which are used to provide one or more user-configurable services, such as encryption, tunneling, and link services. Services interfaces can be provided through a physical services interface card or through software. Services interfaces provided through a PIC do not have ports or media associated with them, but have two-letter interface type designations as displayed. Loopback interfaces, which are used to provide a constant and dependable hardware-independent interface. The loopback interface uses the LO0 designation on all platforms running Junos OS. Use the LO0 interface in conjunction with routing protocols to facilitate routing in a redundant environment that is independent of the individual physical links within that environment. You can configure a single logical unit for the LO0 interface for each routing instance. Each logical unit associated with a given routing instance can, however, have multiple configured IP addresses. Junos OS uses a standard naming convention. Most interfaces have names based on the interface media type, the system slot number in which the line card is installed, the line card slot number in which the interface card is installed, and the port number for the interface card. The CLI almost always refers to line cards as flexible PIC concentrators, or FPCs, and interface cards as PICs, even though the actual names of these physical components might vary between Junos devices. For platform-specific information, including details pertaining to the interface naming convention for your specific device, visit the Juniper Networks Tech Library website. You can access the website from the reference links document. In typical deployments, the slot and port numbering begins with 0 and increments based on the system hardware configuration. The example shows a sample interface name that illustrates the interface naming format. This interface name is for the fourth physical port number 3 on a Gigabit Ethernet interface card installed in the third slot number 2 of a line card that resides on the first available line card slot number 0 of a chassis. Other interface name designations exist, which do not adhere to the naming convention. Interfaces with specific designations are created by Junos OS and are not directly associated with or dependent on physical interfaces. Some examples are LO0, Loopback Interface, AE, Aggregated Ethernet Interface, and IRB, Integrated Routing and Bridging Interface. Junos OS also creates a number of internal interfaces. These internally generated interfaces are non-configurable. Some examples are GRE, Control Channel for Generalized MPLS or GMPLS, MTUN, Multicast Tunnel Interface, IPIP, IP over IP Interface, and TAP, Flow Tap Service Interface. Note that the interface support varies between the different Junos devices. For support information, always refer to the technical documentation for your specific product. Each physical interface descriptor can contain one or more logical interface descriptors. These descriptors enable you to map one or more logical, sometimes called virtual interfaces, to a single physical device. Creating multiple logical interfaces is useful in environments where multiple virtual circuits or data link layer connections are associated with a single physical interface, such as in tagged Ethernet. Some encapsulations, such as the point-to-point protocol, or PPP, support only a single logical interface, and its logical unit number must be 0. Other encapsulations, such as tagged Ethernet, support multiple logical interfaces, so you can configure one or more logical unit numbers. Some network protocols use circuit IDs to identify a connection between two networks. The unit number and the circuit identifier are different in meaning. The circuit identifier identifies the logical tunnel or circuit, whereas the unit is used to identify a logical partition of the physical interface. Although not required, it is generally considered best practice to keep the unit number and circuit identifier the same. This practice can greatly aid in troubleshooting when you have many logical circuits. Junos devices can have more than one address on a single logical interface. Issuing a second set command does not overwrite the previous address, but rather adds an additional address under the logical unit. Using the CLI's rename command is an excellent way to correct addressing mistakes. An example usage is displayed. Also note that Junos OS forms Interior Gateway Protocol, or IGP, adjacencies over all subnets when the IGP is configured on a logical interface. This behavior is worth noting because some vendors' products form an adjacency over the primary address of an interface only. This list provides details for some physical interface properties: Data Link Layer Protocol and Keep Alives. You can change the Data Link Layer Protocol for the particular media type, for example, PPP to Cisco High-Level Data Link Control or Cisco HDLC, and you can turn Keep Alives on or off. Link Mode. On Ethernet interfaces, you can hardcore the duplex setting to either half duplex or full duplex. Speed. You can specify the link speed on certain interface types. Maximum Transmission Unit, or MTU. You can vary the size from 256 to 9,192 bytes. Clocking refers to the interface clock source, either internal or external. Scrambling refers to payload scrambling, which can be on or off. Frame Check Sequence, or FCS. You can modify to 32-bit mode. The default is 16-bit mode. And diagnostic characteristics. You can enable local or remote loopbacks or set up a bit error rate test, or BERT. This list provides details for some logical interface properties. Protocol family refers to the protocol family you want to use, such as Family iNet, iNet 6, ISO, MPLS, or Ethernet switching. Addresses refers to the address associated with the particular family, for example, IP address using Family iNet. VLAN tagging refers to the VLAN tag. Firewall filters refers to the stateless packet filtering configuration. A stateless firewall filter enables you to manipulate any packet of a particular protocol family, including fragmented packets, based on evaluation of Layer 3 and Layer 4 header fields. You can apply a stateless firewall filter to an ingress interface, an egress interface, or both. And other characteristics. Some other configurable options include RPF check, policers, and accounting. All interfaces have the same configuration hierarchy organization. Junos OS takes into account all properties defined directly under the interface name to be the physical properties of that interface. The unit number represents a particular logical interface or sub-interface. Junos OS takes into account all properties defined directly under the unit number to be the logical properties of each particular sub-interface. a basic configuration example that includes multiple protocol families configured under a single logical unit and multiple IP addresses configured for a single protocol family is shown. While a single logical unit does support multiple protocol families, such as iNet and iNet6, you cannot configure a second protocol family in conjunction with the Ethernet switching protocol family. The Ethernet switching protocol family is used when the port is to be used for Layer 2 switching. It is shown in the example. The example also highlights the use of the preferred and primary configuration options. The preferred option is used when you have multiple IP addresses belonging to the same subnet on the same interface. This option enables you to select the source address to be used by packets sent by the local system to hosts on the directly connected subnet. By default, the numerically lowest local address is chosen. When an address is marked as preferred, it overrides the default behavior and can be used as the source address when trying to reach an address on that same network. The primary address on an interface is the address that is used by default as the local address for broadcast and multicast packets sourced locally and sent out the interface. The primary address flag also can be useful for selecting the local address used for packets sent out as unnumbered interfaces when multiple non-127 addresses are configured on the loopback interface LO0. An unnumbered interface is an interface without an explicitly configured IP address. Instead, it derives the IP address from another specified interface. By default, the primary address on an interface is selected as the numerically lowest local address configured on the interface. The interface configuration output shows which addresses are in the primary and preferred state using the Junos OS default behavior, without any specific configuration of primary or preferred statements. In this example, 10.20.30.1, 172.16.100.1, and 192.168.150.1 are the preferred addresses, as indicated by the isPreferred flag, for their respective subnets. That means when this router sends any packet destined to any host in the subnet 10.20.30.0/24, for example, to 10.20.30.40, the 10.20.30.1 address, the preferred address for this subnet is used as the source address of the packet. Similarly, 172.16.100.1 is used as the source address for any packets sent from this router to any hosts within the 172.16.100.0/24 subnet. Same thing applies for 192.168.150.1. This IP address is used as the source address for any packets sent from this router to any hosts within the same subnet 192.168.150.0/24. And the primary address 10.20.30.1 in this example, as indicated by the isPrimary flag, is used as the source address when sending packets to any other subnets, other than 10.20.30.0/24, 172.16.100.0/24, and 192.168.150.0/24 that do not belong to this router through this interface. It is also used for multicast and broadcast packets. This second interface status output shows the primary and preferred state once the preferred and primary options are added. The preferred address for the 172.16.100.0/24 subnet is currently 172.16.100.3 as indicated by the isPreferred flag. Also, the primary address is changed to 192.168.150.1 as indicated by the isPrimary flag from 10.20.30.1. Note that there can be multiple isPreferred flags, one for each subnet, on an interface, but only one isPrimary flag. Though multiple primary addresses can be configured, the numerically smallest of all configured primary addresses get selected as the IS primary address. Note that the interface support varies between Junos devices. Refer to the Juniper Networks Tech Library website for detailed information for your specific product. You can access the website from the reference links document. What is the primary address for GE0/0/2 interface for the given configuration? When multiple addresses are configured with the primary keyword, the numerically smallest of all these candidates is chosen as the primary address for that interface. While both 172.16.100.2 and 192.168.150.1 are candidates for primary, the numerically smallest of these two is marked with the IS primary flag, indicating that 172.16.100.2 is the primary address for this interface. To quickly verify the state of an interface, you can issue the Show Interfaces terse command. To filter the displayed output to an individual interface, add the name of the interface. In this sample output, the admin and link status, the protocol family details, and the address information for the specified interface are shown. When a user administratively shuts down an interface with the Disable command, the admin column shows down for that interface. If a physical link is down due to a faulty connection or disconnected cable, the link column shows down.